All right, let's talk about Cisco's Nexus Dashboard Orchestrator, or what everyone calls NDO. You know, if you've ever been in the trenches trying to manage multiple data center fabrics that are spread all over the place, you absolutely know the headache of keeping network policies consistent. Trying to do it manually at each site, it's slow, you're just begging for errors, and it just doesn't scale. Well, NDO is Cisco's answer to this whole mess. It's built to be that one conductor, that single control plane for your entire multi-site network.
So here's our game plan. First, we're going to set the stage and talk about the real challenge of multi-site orchestration. Then, we'll dive into the different ways you can actually deploy NDO. After that, we'll get into the real power of the platform, which is all about schemas. And finally, we'll walk through the day zero setup and take a quick spin through the user interface.
Okay, think about it. In any modern business, your apps and your data are everywhere. That means you've got these separate data center fabrics, maybe one in New York, another in London, and each one has its own brain, its own APIC controller. Now, the big problem is making sure that a security policy you create in New York can be stretched seamlessly and, more importantly, consistently over to London. Without a tool for orchestration, you're stuck in this nightmare of manual configs and endless validation. It's just a huge, monumental task.
And that right there is where NDDO comes into play. It acts like a centralized brain that sits on top of all the individual site controllers. It gives you that single place to go to provision, to monitor, and to manage policies across all of your Cisco ACI sites. What this really means is you can define a policy one time, and you can be sure that it's enforced the exact same way everywhere, which completely gets rid of that dreaded configuration drift between your data centers.
Now, here's a really critical point about the architecture you have to get. NDO is not some standalone box you just rack and stack. It's a software application, and it runs on the Cisco Nexus Dashboard platform. You can almost think of the Nexus Dashboard as the foundational operating system for your modern data center. It's the platform that can host all these different services, like Nexus Dashboard Insights for analytics, and, of course, NDO for orchestration. It really is that central HUD for all your data center operations.
So knowing that NDO is an app that runs on the Nexus Dashboard platform, the next question is pretty obvious. How do you deploy the platform itself? Well, there are two main models, and which one you choose really just boils down to your specific needs for scale and geography. On the left, you've got the centralized model. This is perfect for, say, a huge campus environment where you might have multiple ACI fabrics pretty close to each other. It lets you scale way beyond what a single fabric can handle, but you still get to manage them as one big logical system. Then, on the right, you see what's probably the more common setup, the geographically distributed model. You know, you got sites in San Francisco, New York, and Paris, all tied together over WAN. NDO is what gives you that central management plane to orchestrate policy across those huge distances. Right, so while NDO gives you this feeling of logical centralization, we can't just ignore the laws of physics, can we? Latency is a huge design factor here. The round-trip time between the Nexus Dashboard nodes themselves can be up to 150 milliseconds. And from that central cluster to any ACI site it's managing, you can go all the way up to 500 milliseconds. This is exactly why it's absolutely crucial to have quality of service in place. You have to mark that internode traffic with a high priority, something like EFDSCP, just to make sure that vital control plane communication never gets dropped or delayed.
Okay, now we're getting to the absolute heart of NDO's power. Unifying policy. This is about so much more than just connecting things. It's about being able to define your networking and security rules one time, and then letting the orchestrator handle translating and deploying that intent consistently, no matter how many sites you have. This just dramatically cuts down on human error and makes delivering new services so much faster.
And look, you don't just have to take my word for it. The source material flat out says this is one of the most important features. This whole idea of creating an inter-site tenant policy profile, which is just a fancy way of saying a container for all the networking stuff like VRFs, bridge domains, and EPGs for a specific app, and being able to stretch that across your entire infrastructure, that's the core value right there.
This diagram just shows the concept perfectly. Up at the top, inside the NDO template, that's where we define our policy. So for example, EPG1 could be our web servers group, and EPG2 could be our database servers. That C in the middle, that's the contract, the rules that say exactly what traffic is allowed between those two groups. By just tying this one template to Site 1 and Site 2, NDO automatically pushes all the necessary configs down to both ACI fabrics. It guarantees that the security policy between your web and database servers is identical everywhere.
Now, when you're actually designing these policy schemas, you have a pretty basic choice to make.
For smaller setups, a simple design is totally fine. One schema, one template, and you just throw everything in there. Your VRFs, your EPGs, all of it. But for large-scale enterprise deployments, the best practice is definitely to separate them. You create one foundational schema for all your core networking stuff, and then separate schemas for each application. This modular approach isn't just for keeping things organized, it's really important for avoiding scalability limits in the system. It also lets different teams, like the network folks and the app folks, manage their own policies without stepping on each other's toes.
All right, enough theory, let's get practical. What does it actually take to get NDO up and running? Let's quickly walk through the day zero operations. The basic foundational steps you need to take to get your sites onboarded and under NDO's central control.
The whole process is actually very logical. Step 1, you add your sites. This just means registering the APEC controller for each fabric with NDO. Step 2, you configure the inner site infrastructure. This is usually setting up the BGP EVPN control plane that lets all the sites talk to each other. Step 3, you define your tenants. You can either create them from scratch in NDO or just import their configuration from a site you already have. And finally, Step 4, you build out your schemas and templates and apply those policies to your tenants.
So once you've got everything configured, where do you actually go to see it all in action? Let's take a quick look at the NDO user interface, which is really designed from the ground up to be that single pane of glass for your entire multi-site world. The very first thing you land on is the main dashboard, and it gives you this fantastic, high-level geographical view. You can instantly see the health of every single site on the map, and it's all color-coded to highlight any problems. If you hover over a site, you get key details, like the APIC controller health and the overall fault score. For any network operator managing a global infrastructure, this is just an incredibly powerful at-a-glance snapshot of your network's health.
The whole UI is organized really nicely into 4 main areas. We just saw the dashboard, which is for that high-level health check. Application management is where you're probably going to spend most of your time defining tenants and building out those schemas we talked about. The operations section is for all your daily admin tasks, like taking backups or checking audit logs. And finally, the infrastructure section is where you manage the real foundational stuff, like site connectivity and the core system settings.
So, to wrap it all up, NDO really just ties everything together. It's not just some tool for pushing out configs. It's a complete platform that gives you unified health monitoring, simplified policy provisioning, and full lifecycle management for your entire multi-site network. The end goal here is pretty simple. Get consistency, get visibility, and get control across your entire data center footprint.
And all of this leaves us with a final question to think about. We've seen how NDO provides this really elegant solution for the on-premise multi-site challenge. But as more and more organizations move to hybrid models that stretch into multiple public clouds, how are these tools going to evolve? What does that next generation of orchestration even look like for a network that truly has no boundaries?